All right, so 7.3 part 2, more graphing, and the first thing you're going to notice about this equation, it's not in our standard form. It's not set equal to 1. So what we're going to have to do is divide both sides by 36. So if I divide 36 by 36, I get a 1. If I divide 36 into 4, that reduces. 4 goes into 36 9 times. There's my denominator. And vice versa. Put 36 underneath the 9, reduces to x squared over 4. So center still at the origin. No one's being added or subtracted to my x's. A squared is going to be 9. So we'll plot our center. Then we're going to go up and down 3. Then b squared will be the 4. Take the square root, which is 2. We'll go left and right 2 for your covertices. And we'll draw in our ellipse. Again, we still want to plot our foci, so we'll get our Pythagorean theorem with the minus sign. 9's the a squared, minus 4 the b squared. 9 minus 4 is going to be 5. Square root of 5, well, we really can't take that. It's irrational, so positive or negative square root of 5 is going to be really close to 2.24. So we'll plot those points somewhere in the ballpark there and label them as capital F. And again, finding the coordinates, always starting at the center, in this case the origin. Add and subtract 3 to the y coordinate for the vertices. Covertices, add and subtract 2 to the x coordinate. There's your covertices. And add and subtract the square root of 5 to the y coordinate of the center because it's always the same as the vertices. There's my foci. All right, now in the next example, we're moving our center. So again, that's saying find the x, change the sign, positive 2. Find the y, change the sign, positive 1. Let's plot 2, 1. 36 is bigger than 9, so that's your a squared. So the square root of 36 is 6. We're counting left and right 2. Label them with capital V. B squared is 9, so take the square root of 9 is 3. We're counting up and down 3 to our covertices. And again, draw in your best looking ellipse. Now again, one thing you want to do is you want to kind of make sure you stay inside. If you think about your vertices, here the major and minor, they make a rectangular box. We want to make sure that ellipse, especially when you're getting near those vertices, don't miss them going long. Don't go off to the side. Stay on those vertices. To plot our foci, again, we have to go find the c using the Pythagorean theorem with the minus sign. 36 is a, b squared is 9. 36 minus 9 is going to be 27. Take the square root of that. That's going to be, well, let's see, 27 has a factor of 9, so the square root of 9 is 3, so we can factor one of the 3's out, and 1 3 stays on the inside. And the square root of 27 is approximately 5.2. So we're counting left and right, 5.2. That's where our foci will be located. Now, it's a little bit different here when finding the coordinates. You still start with the center. But now when you put that plus or minus 6 underneath the x, you can't write it as 2 plus or minus 6 comma 1. You have to write this as 2 separate points. We can simplify 2 plus 6. It's 8 comma 1. 2 minus 6 is negative 4 comma 1. The y coordinate doesn't change. Same with our covertices. Our up and down 3 will be added and subtracted to the 1. So 2 comma 1 plus 3 is 4. And 2 comma 1 minus 3 is negative 2. So there's my covertice points. And however, now for the foci, because it is a radical, plus or minus 3, square root of 3, being added to your x coordinate, same as the vertices, you can leave this with the plus or minus in it because we can't simplify it. Okay, next example. x plus 3 squared over 4 plus y minus 2, all that squared over 25. Find the x, change the sign, -3. Find the y, change the sign, +2. That's my center. Plot that point. A squared is going to be your 25. We're counting up and down 5 to the capital V's. B squared is going to be 4. Square root of 4 is 2, so we're counting left and right 2. There's my covertices. And again, we have that skinny looking ellipse here. To plot our foci, we got to go find C. So Pythagorean theorem with the minus sign. 25, that's your A squared. 4 is your B squared. We had the square root of 21 before. That was approximately 4.58. So from the center, count up about 4.5, down 4.5, plot those points, label them as capital F. And again, with the coordinates, starting at your center, -3, 2, up and down 5, we'll add and subtract that to the y coordinate of 2, so -3, 2 plus 5, 7, and 2 minus 5, -3. So -3 starts off each point. Covertices, -3, 2, we're going to add and subtract 2 to the x coordinate, so -1, 2, and -5, 2. Foci, again, that plus or minus square root of 21 being added or subtracted to your y coordinate, we can leave it as 2 plus the square root of 21. Next, we're in general form. We got to convert this to standard form. We have to complete the square. We group the x's and the y's together, and notice I took the plus 9, subtracted it over to the other side. So very similar to our circle, except now those two coefficients in front of the x squared and y squared, they're going to be different values. So to complete the square, the first set of parentheses is okay, second one not okay. Remember, this has to be a 1, so you have to factor the 9 out. And this is super important here. This 9 that you just took out as a GCF, you need to put it into the blank that you were going to use for the y's. Because whatever you put here has to be multiplied by 9. That's what you're truly adding to the left side. So we got to go 9 times that same number over here. So half of a +6 is +3 squared 9. There's my x. Half of -2 is -1 squared is 1. So that leaves me x plus 3 quantity squared plus 9 over y minus 1 quantity squared. -9, +9 cancel, leaving me a 9. This is not standard form yet. We have to divide 9 into both sides. You divide the 9 over into this binomial, 9 stays there. But when you divide it over to the second fraction, 9 over 9 will cancel, leaving a 1. Now, do you have to have 1 in the denominator? No. You could just leave it as y minus the binomial squared, but I like to see it for my a squared and my b squared. So here my center is going to be, find the x, change the sign, -3. Find the y, change the sign, +1. -3, +1. A squared is 9. It's underneath the x. So plus or minus 3, left and right for the vertices. Underneath the y, that's my b squared. That's up and down 1. Those are where my covertices are going. And I draw in my ellipse. Foci, Pythagorean theorem with the minus sign. So it looks like we're going to go a squared 9 minus b squared 1. That's an 8. Square root of 8 is, let's see, 2 square root of 2. Keep that plus or minus there. And square root of 8 is approximately 2.83. Holy cow, we are all over those vertices. We're really, really close. And again, finding the coordinates, always start with the center. Add and subtract that 3 to the x coordinate. You'll get a 0 and a -6 with the same y coordinate of 1. Add and subtract the 1 to the y coordinate. You'll get 2 and 0 with those -3s. And add and subtract the 2 radical 2 to the -3 for the x coordinate, comma 1 for the foci.